This session will focus on FHIR search, where we'll explain core search mechanisms and explore how they're applied in practice, including text searching, composite search, search criteria, and chain search, and more. Before we get started, for those of you who are new to Digital Square, we work with innovators, governments, and donors to support country digital health programs. One of the ways we do this is to support adaptable, interoperable tools that are designed to work seamlessly together. We support this interoperability and this community through webinars like this. So just a quick few house rules. The session is recorded and will be posted on our wiki a little bit later. I will ask that everyone mute themselves during the presentation so that we can hear the speaker. This is a slightly shorter presentation, so we'll have plenty of time for questions at the end. And then lastly, if questions come up or you need to, you're looking for any sorts of resources, we do have a Google Doc that's available where you can find previously recorded webinars, resources, and information about our next sessions. All right, with that, we'll turn it over to Jose, who is a data management and standards and interoperability expert that has worked in the sector for over 20 years. He's the co-chair of the IHE Pharmacy, as well as an avid supporter and contributor to FHIR. And since 2009, Jose has been contributing to global healthcare standards, HL7, IHE, and ISO, and also facilitated the launch of HL7 and IHE work groups in Brazil, Portugal, and Belgium. All right, Jose, over to you.
Thank you, Brenda. While I'm just re-downloading the stuff that you will see today, yeah, let's just drive through the organization of this session. So we have it's a lightweight session today. So as per the other sessions, the session that we have is not supposed to be a formal training. It's supposed to be more of a guidance for you to know, to find your way quicker, or maybe to stimulate some discussion around the topics that we are discussing, in this case FHIR search. And as such, much of what we are going to share today is part of the FHIR specification, plus a few new tricks, like things that we should know, things that would be good to be aware of when we are designing search. It's not only the technical part, but it's like some design considerations. With that, let me see which part of my, oh, I'm not sharing anything. Let me share my video, and let me see if I can share my screen as I open my toolbox. So let me start with the presentation first. So today we have a couple of examples. I'm going to put this on the chat, the link that we are going to use, the tools that I will use just to demonstrate as we are going. So this is going to be a very practical session. I want to show examples of everything. And for this, I will be using a set of exercises that I just put the link to in the chat. So this is what we are going to work with today. Some examples of how to do search. We are going to try several different servers because they have different capabilities at this moment, and they have different data sets. So it was hard to have one server that could address all of these, all of the things that we need to work with. And with that, let me just see if I can bring up the presentation. So it's hard to think and talk at the same time, so I just have to hit the right keys. And I'm going to open this. So let's start then. You will be able to see my screen in a second, as soon as I find the right key combination. Obviously not it. Okay, so sharing my screen. Can you see my screen?
Yes.
Thank you. So we are going through the basics of FHIR today. Much of it, as I said, is going to be is the FHIR specification. I just want to give some quick guide through navigating that, and hopefully save you some time in research and learning, and also give you some tricks, and also listen to your tricks and ideas and concerns so that we can work together on this better. Again, the purpose of this is to create a strong community. It's not for, it's not a one-way communication. It's really to stimulate collaboration around these different the different aspects of FHIR as a whole. So we'll start with what is the search. Well, it's kind of obvious, but just to see some technical details on that. A search can be done with GET or POST request. We'll go a bit into that. We'll see what is a search, how does a search request look like. We'll see how a search response looks like on a FHIR server. We will then go a bit in deep on the search parameters that we can use. So what are the basics there, and some special parameters that we can use depending on the server. We will do some intro to advanced searching, so that you will see what can be done with the basics of FHIR search, and then some design notes, some considerations on the use and specifications using search, because when you do search, you are opening a door to everyone, or potentially everyone, to see every data. So we have to keep that in mind. So, and that in the practical usage, some space for discussions. At any time, please feel free to ask questions or to interrupt. If I really need to continue a line of thought, I will let you know, but I'm happier if we just go through this more as a dialogue to listen to what are your concerns, or maybe we are missing something here in this presentation, or maybe FHIR is not clear in some aspects. So feel free to interrupt and to engage. Just the usual disclaimers. It's not the usual training. FHIR is a registered trademark, and FHIR does not endorse this as a training. This collection is a collection of freely available materials. Everything that I'm going to present there, they are either the FHIR spec or the examples that we made available. Actually, we just updated them today. And this is shared under Creative Commons attribution. So feel free to share as long as you give credits to where this came from. So today we'll understand the basics of FHIR. So at the end of the session, you should be able to understand the basics of FHIR, understand what parameters we have and we can use. Also understand the advanced searches, like chain searches, composite searches, and you should be able to issue any of these searches against your own server if you have one, and some of the details of the implementation. As of now, so this is roughly the program and the expectations. If you feel that there is some big part of search or some expectation that you have in mind or you had in mind, and you don't see it yet reflected here, please put it in a Google Doc, so that we can revisit it as we go, and then we can address it shortly. So let's start then. What is a FHIR search? Oh, sorry, the practical things. The URL that I just sent, that's a link to there's a link to the example. So the search HTTP, the search HTTP file, this allows us to use VS Code, as I'm going to use today, to run the search against the servers. We can use this on a Happy server, on the test.phir.org server, or on a Vonk server. I will try the three of them. And I'll just be running the examples as we go through the session. First thing, where are we in terms of FHIR architecture when we talk about search? So when we talk about search, we are not talking about the resources. It's something that's common to all the resources. It's not about really terminologies, although it has a bit with terminologies, but it's more on how to use FHIR. So the search has a bit of operations. There's one thing that we'll see that's mixing search and operations, and it's pretty much about REST API using GraphQL. So it's part of the kind of transport layer specifications in FHIR. So the key point, as you will remember from previous sessions, is that everything in FHIR is computable and is technically defined. So profiling, searching as well. So besides profiling, searching is also done technically in FHIR, and there's a language for that. We'll see that towards the end of this discussion, but there is a way to express how the search should behave in a given condition, in a given server in FHIR. So what is FHIR search? FHIR search, it works as a filter. It basically tells us what data should be retrieved. That's pretty much the key point. So what we'll be doing is to explore the different ways of how to filter data in FHIR. RESTful search can be done with GET or POST requests. We'll see some of the differences there. It's important to keep in mind that each system can configure its search behavior. For example, does the system respond to GraphQL or not? Does the system, or how many parameters does the system, how many results does the system provide, or does the server provide when you do a search? So if you search for all the patients, if there's 10,000 patients, you will not get 10,000 patients in one response. You'll get a block of those. You'll get 50, 20, 10, depends on the server. So each server can configure its search behavior in the sense of the amount of search results, but also what you can search on and how you respond. So let me just give one example here, going a bit into the business aspect of this that we'll cover at the end. If I search for all the people that live in, I forgot the address, in the number 10, what is the street, the UK Prime Minister address, Downing Street, I think. If I search for all the people that live in that address with a certain age and with a certain type of disease, by doing the search, I am disclosing some potentially sensitive data. So there is also some care to be taken, and the server is responsive for saying, so imagine this search, and imagine that the search says, the response is, there is a patient here, but I cannot, there's a patient that matches this criteria, but I cannot tell you the name. Well, that's pretty much saying that you know the name already. Or the search says, okay, your query has been received. If there's an answer, you will get it. That's completely different. So the systems can configure their behavior in terms of what they should respond to. That will be part of your design specifications on how to handle this. It's just that in terms of, for example, in terms of privacy and security, it's very important that we know what to respond to a query besides the strictly functional expectations that we have on the data. So the systems can configure its search behavior, but we can also influence that from each search. So in each search, we can say, I know that the server gives me 50 results, but I just want 10. So we can do something, or I know that the server gives me JSON, but I really want XML as a response. So some individual search capabilities can be configured or can be parameterized on the client as well. So for each query, we'll go through that. We'll go through all these examples. So let's start with the anatomy of the FHIR search. FHIR search request. The FHIR search request is can be a GET or a POST. So let me just move this box up here. And basically, we are pointing at a server, and so the base is the base URL of the server, and the type, which is optional, is the type of resource. And we can say from this server, and if the type is patient, get me the patients, or get me the patients that meet this parameter value. So that's pretty much what it comes to. So it's really like, for those of you familiar with query and any other query language like SQL, it's select where this parameter has this value, this parameter has this value. It's really simple. The same thing with a post. So you can issue a post request or a GET request. Technically, they are pretty much the same. They are just expressed differently, where the body of the, so whether the search parameters, they are either in the URL or they are in the post body. There's a small difference to that. I'll check that in a second. But this is a simple thing. Anatomy of a search request is you have the server base, you have the type of resource, which is optional. You can issue queries against the whole server. So you can say, show me everything that has been updated yesterday. You can do that. regardless of whether it's a patient or a condition or an observation. But you can say, get me the patients that have this date of birth. So that is what the search request is going to be composed of. And as a response, we have always a search. The search response is always a bundle. So bundle is a FHIR resource type. And whenever we have a search, whether the search returns results or not, except if the search is not well formed, but if the search is correctly issued against the server, whether there is a result or no matching results, the resource type, the response is going to be a resource type bundle with a type search set and a list of entries. So the entry list can be empty if there is no results, but the entries, they contain the full URL to the resource that has been found, and then the actual resource that has been found. So if I went here to this URL, I would click and I would get exactly this resource, but the search actually gets, by default, the search actually gets the resource as well, the resource content as well. In addition to this, there is some navigation aids that are slightly different from server to server. But when you have you have a couple of links, and those links typically this is a search that was executed. So this is the URL that I actually used to get this. And basically the search says, get me the patients without any parameters, which means get me all the patients. That's as simple as that. And there is also some sort of paging or navigation links that we say that can have this. And this is the URL to get the next 20 results and the next 20 results and the next 20 results. So this is because the server that I was running this against, it has 20 as a default of count of so the default amount of search results that it returns. So if I want to get the next 20, there is a link. Every time I run a search, I get these kind of links to help me navigate in the next results. But it's pretty much this. All the searches that we are going to do, except the last part in GraphQL, they will have a search result, which is a bundle resource, and then of types search set and with a couple of entries. Yep. And so, how is FHIR distinguish between the? So how can we distinguish the search between simply getting a resource? Getting a resource is one thing. So if I go to the server and say, get me the patient with this ID, then I'm just getting this. That's not a search. So this is it. The patient with this ID or with this internal ID, that's not a search. Everything else that you see on the screen is a search. Whether I put parameters or I don't put any parameters, that's always a search. And the search always return a bundle. So with this in mind, actually, I just kept some notes here to start showing in practice how this works, and if the server gods have been kind to us, the server should be alive. So I'm just going to work with the file that I sent you. Here I just use different hosts. Let me just, oh sorry, this is the host. So I have three different hosts that I can use. So host 1 is the FHIR, host 2 is Graham's reference FHIR server, and host 3 is the Vonk server at FHIR. At this moment, for most of my queries, I'm going to use the Happy server, just because that's the one I had in the beginning. In terms of preparation, I don't think I need to do this, but this is just me populating a list if we have to. If I see this is missing, I will come back to this. So let's just run this. If I send this request, so first of all, let me ask, can you see my screen? Can you read my screen?
Yes.
Okay. So I just clicked here on send request. So the VS Code extension that I put the name there, it just transforms a file called HTTP or it just adds this possibility to send a request. So I'm just going to send a request for getting one patient. And so I just click here on this line 30, between line 32 and 33. So the example number 2, getting a patient resource by its ID. I just click on it. So I'm going to the host and get patient with this ID. That's simple. And this results in a patient resource because I'm not doing a search. However, if I go and do a search for all the patients, I will get as a different response. I get a bundle, and that bundle will have entries, and those entries will be of type patient, as you see. So it's pretty much down to this. So what else can we do? Oh, this is missing here. I can do this here. Sorry, I just deleted the accident by accident. I'm just going to show you. Then I'm going to explain that later. If I want to search for a patient by its ID, knowing that ID is one of the search parameters that we can use, what I just composed here is a search on a patient where the internal ID is this one. Functionally, this is the same as this one. It will get me that patient if it exists. However, if that patient does not exist, it will give me most likely an error. So it gives me a patient resource. If the patient resource does not work, let me just add something here to see if I can cheat on this. This should give me an error. Yeah, exactly. So 404 not found. And it tells me that this resource is not known. I'm going to do the same thing with the search. If I do the search, I will get a bundle of one result. So here's the bundle. It actually tells me there's a total of one, and it has one resource here. So this is the whole resource. It is here. So patient with that ID. If, however, I now add something here, can anyone guess what is going to show me? Just to break the silence and to get some water. No guesses? That means it's too boring, or I'm going too fast, or it's, yeah. So
I'm guessing a result with a total of 0 or a null result.
Exactly. So it will get me an empty bundle or an empty list. So it's a bundle, total of 0 and nothing. So no entries in my results. That's it. It's really what it comes down to. So going back to the slides, there's a couple of searches. We'll do them all today. So these are the searches that we can run, but it's always the same thing. So if I'm talking about a get search, I put the question mark to say here there's a query coming, and then I put parameters and values, parameters and values, parameters and values. So in this case, I put the parameter _ID. This is actually one parameter, and another parameter here is the identifier. Another parameter is the birth date. We'll see where those come from. So this is, oh, by the way, everything that we are going to discuss here is detailed. So all the specification is detailed in one single page, which is the search page. There is a few add-ons to this, like the REST API part of FHIR, but all the functional content is in this link. So resources can be searched by using their search parameters. So each resource has their search parameters. We'll get to that in a second. And a server can be searched across resource types, as I said. So if I want to say, get me all the resources that have been updated yesterday, or get me everyone that has a birthday today, regardless of whether it's a patient or it's a physician that's working here, that can be done against the server. We don't have to run type by type. We just do this on a global search on the server. So a bit more in detail on how the search goes in terms of get and post. This was as was before. So in this case, when I do a search, I put the host, I put the resource type, since I'm doing a resource specific search, and then I put the parameters, and everything goes into the URL. So the search parameters are all in the URL. It may or may not, but it may have some security implications. So this is not to say that you should use one or the other, but just to raise awareness of the problems that may arise here. If you do this, then the URL that you are requesting, it will stay on the system logs, and depends on how deep your system logs are. If you capture everything, or if you just capture the URL, there might be some sensitive data in the URL itself. So in that case, for those cases, you might want to have just a post message. A difference, if it makes a difference, it would be if in that case, if your audits they capture the URLs, but they don't capture the body. If you capture the body, then you still have the same problem, or maybe you have different ways of addressing this. But this one apparent advantage or possible advantage is this matter of not disclosing upfront with the URL all the information. I think the more important advantage is that the URLs have a size limitation. I do not know how many characters. It's quite a bit, but it's not that much for a complicated query. And the posts don't have, I mean, the size limit on the post body. I don't even know what it is, but it will not impact the same way that the URL will impact us. So in the content body of the post search, you can put as many parameters as you want, and it's just one big blob of text that's going to be sent with the query. So there's no size limitation as we have in the URL. Other than that, they are exactly equivalent. The only difference is how you call them. So you do patient/_search and then you open the parameters, or you do patient ? And then you put the parameters in there. So let me see if, yeah, I have this. So just to show how it works, or just to prove that it works, I'm not inventing anything here. Number 7. So this is the post search. It's the same thing, searching for one ID, but just using a post request. It works exactly the same way. If you go to the FHIR search page, let me just go there. So when you go to the FHIR search page, first thing that comes up is indeed the list of, or the summary of the parameters that we have. These are parameters that apply to all the resources. So all resource can be searched by ID, which is actually what I just did in the example that I just put here. So that's the ID. This is one parameter that I can use. All resources can be used on the last updated date. So I can do that query that I mentioned, like show me everything that has been updated today. And so all these, they can be searched by tags or profiles or security content, or by text is a special search thing that we'll see later. Content, the same, looks into the content of the resource regardless of the position or where it is. List is something that we are going to do today, has as well, and type, I think we are also going to look at that. So we are going to look at that. These are parameters that apply to all resources. So they can be used in a resource search or in a search or in a server-wide search. And there's parameters that we can use to conform or to change the result type. So we can sort. We can only get the count if we want. We can include resource and related resources, or we can just have the summary, not the full resource, or we can just have the total. Or we can have specific elements, not the entire resource, but just some elements that we want. We are going to experiment with these queries. So this is one important thing, is what parameters we have. And going back to my presentation. So just see, where is my? Yep. So all resources can be searched by ID or type, etc. The patient, for example, can be searched on status name, but it's not searchable on marital status. How do I know this? So this is one of the important parts when we are designing FHIR systems. Always look into the resource to see what it can be searched for. So if I go in here and open the patient resource, how do I know? So patient has lots of attributes: identifier, active, name, telecom, gender, etc. It has things like where's the marital status and address. How do I know that I can search for name and even gender and identifier, but I cannot search by marital status? It's simple. At the end of every resource definition, you have the search parameters that are on that resource. So this basically says that patient can be searched on the active. So there is an active search parameter which maps to patient.active. So this one is simple. Address, and that maps to the whole address. So if I do a search on patient with the address, I'm going to search the entire address data type. Or if I just want to search the city, then I don't use the address, I just use the address city. That's a different search parameter that I can use. Or address country, or address postal code, or address state, or address use. So these, the key aspect here is that the patient resource defines what search parameters are allowed. And each search parameter, which is typically in this form, so it's either a single word or several words separated by a dash, they map internally to some expression. For example, the patient deceased is a search parameter, because if you look at the patient resource, that's actually an interesting example. You have patient deceased can be a Boolean or can be a date time, but at some point you just want to see, are the patient dead, and that might mean that the flag is set to Boolean. If you don't know the date, you set the flag to Boolean, or that you don't set the flag, you just put a deceased date. And in that case, how could you search? Well, to make that simple, you have a deceased search parameter that internally resolves to this. So if the deceased is not false, and so if there is a value there, whether it's a date or a Boolean, then if it's not false, then the deceased flag or deceased search parameter resolves in true. And as you can see here, there is nothing about marital status. So if you look into this, you cannot search in marital status. Let's try it on then. So if I run this, so if I run the patient to marital status, and I can make this a more complicated search, I will share with you how this detail works. So I could just do this. You as is unmarried, but this search would be valid if the marital status would exist. But what I get from the happy server is that unknown search parameter for patient. So this does not exist for patient, and it even tells you what valid search parameters you have. Content ID. So you remember these were the global ones. These can be used for all the resources. And then for patient, you have active, address, city, etc. So these are the search parameters. So one really important thing is, as you go through this, as you specify, you might want to say, can I search on this? Do I want to search on that? Sometimes you need to add search parameters to a resource, to a profile. That is also possible because, as I mentioned before, everything is computable in FHIR. So there are ways to do that. We'll check that later today. So patient can be searched on everything that has been given a search parameter on the FHIR resource definition, but not searchable on whatever we want. Another thing that we have is the response parameters. Just let me, what is this? Oh, right. Oh, I made a mistake here, but this is number 9, not number 8. I can actually say which format I want to receive my information. So if I get I just want to get this patient, and I issue the request, I get a JSON. But actually, I already said that I want to have JSON. But what if I say I want a specific format? I can do that as well. So I can say I want the format to be XML. This is just a technical thing that technical header that I sent to the server, but I can actually force and say, I don't care, I need XML because that's what I can read, or I need JSON because those are my libraries. So we can force the format of the response. We can also play a bit with the content of the response. So if I get that patient, so if I search for patients, I will normally get everything that's in the patient resource, all the attributes. But sometimes I don't want to get all the attributes. So there's a couple of things that might be important, or might be relevant, or might become relevant somehow, or somewhere along your path of using this. Resources, I can get the summary of the resource. So let me just do this to see how it looks different. So this is, I just got all the patients. I did not even put a specific patient, but let me just put the specific patient here. And I say summary is true. When I say that, I have here a thing that says that this is subsetted. So the resource is encoded in summary mode. So just to tell me, so the bundle, sorry, the resource type is saying this is the this is being yeah, sorry, I should have done this patient score. That's a search. It's going to be a bundle. Oh, it doesn't work. Oh, because I made a mistake. It works. So now I have a bundle, and whatever response I get, whether it's a patient or a bundle, now I'm doing a search, so I get a bundle. It says this is subsetted. Be aware that this is not a full resource. That's pretty much what it says. And the patient here does not have all the data. Let me just do a quick comparison to see if I'm saying the truth. So I have 109 lines total. If I remove the summary, let me see how many do I get. Oh, I get the text. For some reason, I get more content, but in less. Well, no, it's not less lines, is it? Sorry, 99. Yeah, I get more lines here because of the subsetted thing. Because of this. But for example, here I see the identifier as the first thing, and if I remove this, I will actually not have. If I remove this, I will have the text. So if I put the summary, then the text, for example, is hidden. So there is a difference between calling something with a summary true and the summary and not the summary. So I can request the summary or the entire resource. How do we know what the summary will result in? That's very simple. We go to the patient resource, and there is a small sigma letter that says this element is included in summaries. So if I go to the patient and if I do search and say summary is true, I will get the identifier, the active, the name, telecom, of course, if they exist. But I will not get the marital status. I will not get the multiple birth, and I will not get a photo. So this is pretty much the logic behind this. I'm just going to open here the domain resource to explain why. So the domain resource, actually, there's no flag here. It should be. No, sorry, it's correct. The text. So the text and contain. So these are common attributes to all the FHIR resources. That's why in my bundle I have a text. In my patient I have a text, and patient has a text attribute, but the text is not part of the summary. There is no summary flag here. That's why when I put the when I do the summary is true, the text is gone, and if I have the marital status, it would also be gone because I'm just selecting the fields that are in part of the summary. This is interesting, and it can get more interesting if I want to say, well, how do I get not the summary, because that's some arbitrary decision or some decision that has been taken by HL7, but I just want to get only the fields, only the data elements that I'm really interested in for my small mobile app. I don't want to get the whole thing. I just want my element, my preferred elements. There is an additional search parameter, which is this underscore elements. And I can say, get me the name, the active, and the link, if that is what I want. I just do this. And see here, I get a bundle with lots of patients. And for each patient, I have meta, just to say this is subsetted. That's important. But then I have the name and the active and link if they exist. And this does not have it. And yeah, so it's because the active is not there, then the active is not shown, of course. I can change this, and I can add the FHIR. And at this moment, I'll now have the name and the identifier, and of course, the active and the link if they exist. This is pretty much what we can do. So we can shape the response of the server. We can also sort. Sorting is an interesting feature. We can sort by different search parameters. So again, search parameters are those that are in the resource. So those at the end. And the common search parameters, those. So I can search by any of these and any of these, and I can sort by any of these. So in this case, let me just, so I want to sort by name. Now I will do this. This takes a bit because it's getting all the patients. It really takes a bit. Let's hope it doesn't give up. Okay. Yep, 12 seconds, and it got me a lot of stuff. Sorted by name. I don't want to confirm. At this moment, I trust the server that it does sort by name. But maybe I want to sort by birth date, or I want to sort by status. So I can put these parameters, the search parameters there. And if I want to sort in a descending order, then I put a minus before the search parameter. So in this case, I would search all the patients and sort by birth date. Descending, this means that I will get the youngest patients first. Let's see how that works. This kind of search starts to be a bit heavy on the server. So if you want to do this intensely, you might want to roll out your own server to do these tests. So let's see where we have birth date. Yeah, I don't have it. Oh, right, I remember. So at this moment, I'm getting a bundle, and I should get, I think I'm getting like 20 responses, but maybe in those 20 responses, none of them has the birth date in there. So it's not going to sort on something that does not exist. So I think maybe, oh, sorry, it is sorted. Why is it not? There was another case where this was not working, and that's the next use there. Oh well, and it's just my tool that's not working. But here's the birth date. Yeah, this seems like a very recent, very young patient, and we have those birth dates. So it's sorted by the birth date. To be honest, I do not know if it's missing. I don't know if it puts it to the end or to the beginning. I thought it would be to the beginning, but apparently not. It's to the end. So yeah, we have all the birth dates. Okay, this is an older patient. But yeah, so those are the birth dates. That's the sorting that we have in this case by birth date descending. Where was I? Yeah, birth date. So if I do this search, I can get 10 or 20. I don't know how many results by default on the server. If I'm just going to do this on the other server, so this was on host 1, this is on Happy. Now I'm going to run a query against Vonk server. Yeah, and the Vonk server, there it is. I'm getting everything. So this is a search. So this is actually a server-wide search. So let's go a bit into the detail here. It's a server-wide search, and I'm searching for all the resources. So you see here, there's no resource type. So I'm just searching across all the resources where the name is R, or actually in this case, where the name contains R. So if this means that's most likely a lot of patients, but I don't want, sorry, a lot of resources, but I don't want all the resources. Actually, I just want patient and practitioner, because the name might not exist for other resources, or I don't care if there is a care plan with a name, with an R. I care about people with a name. Let's say I use these two. I want to have only these two resource types returned. The parameter that I use there is _type. So again, it's one of those common. Where is it? Yeah, here. So I can say, get me only the resources that are of this type, or this type and that type. We will see that later, or we can see that now. The comma means or in this case. So here the comma means it's a sort. So sort first by date descending, and then if they match, sort by name. Here the name is getting these. It's a list separator. Here when I put the type, this is an or. So get me the patients where the type is practitioner or the type is patient. So when I ran this, I get everything that is either a practitioner or a patient, and I think I have 10 results here. Let's see how many lines I have. 681 lines. If I do here, if I say I want the count to be, sorry, I see it here. The total is 11, and if I did go through the count, I would say these are only 10. I only have 10 here. So the survey is telling me there is 11 matches. I just gave you the first 10. So what I could do here is to use this navigation to say, go to the next one. So it's count is 10, but skip the first 10. So get me the next 10, and it will get me the new one. Or I can just tell the server, no, never mind, just give me 20 at a time. And if I do this, then I will have more resources. So I have 700 and something lines. And there is no next here because there is no, there's no next entries. This is it. So this is one more parameter that we can use. Let me just look at the time, how we are. We are actually quite good. I wanted to have some more detail into the search parameters. So let me just go through the presentation. So we have seen the pagination, like the count. We have seen the sort. So some servers do support free text search. I'll get to that in a second. And some servers also support searching resources from a list. For example, I can say, get all the medication statements, but not everything about this patient, but only the ones that the doctor has actually put in a list. So there's a list resource. And if some doctor says, okay, from now on, I declare that this patient's relevant medication statements are these and these and these. If he puts that on a list, just as a cherry picking, then we can use that to get in a query as well. So before we get to the more advanced things, let me do that. How do I do search by text? There is a special syntax. What I'm doing here is the slides to show. I'm going to search for resources that have the text John Mark, and they also have the word glycoside. I don't know if that's how you pronounce it. Word in it. So I want resources that have this text, or this text near that text. There is a whole specification to this. It's written on the search page in FHIR on the specification. But this is it. So if I go to this server that does support text search, and this is the expression, so I have the John plus Mark, so this is space, John and Mark near glycoside search. If I run this, I am just getting, actually I just got one, So that's the, I'm running against the medication statements. If I don't put the search, or if I don't put the text search, I will get just all the medication statements, which are quite a bit. If I just put the text, this text, then I get only those that have that text. And you can see here, John Mark. So it's not one single string; it's one string next or near the other string. So that's the behavior of the server. Each server will have slightly different behaviors. Some servers do not support text search at all. What they actually search on depends on the indexing on the server. So that it really varies from server to server. I just wanted to give you a quick input onto this. There's a search indexing running in the server, so you can use this for fuzzy word searching and stuff like this. So this, whatever purpose we can use it for, it's available in some servers. Conversely, if I have the list, so if I have all the medication statements for that patient, which I don't have here, I will have, I think, like 12 or 13 medication statements. Let me see how many I get here total. I think in this server I only have, no, this is 39, but okay, for this patient I would only get 13, I think. I remember from yesterday. Sorry, I don't have it at hand and I want to move ahead. Trust me on that. This patient has several medication statements, but in preparation for this, I made a list, and I call this list P1023 meds, and that list, there's a resource of type list that includes several resources. So this is what I was mentioning just now, that the doctor says, okay, for this patient's list, so the patient 1023, the relevant medication statements according to this list are medication statement 1, 2, 3, 4, 5, 6, and 7. If that's the case, I can actually go here and say, get me the medication statements that are part of this list. So if I say, get me all the medication statements that, let me see if I can do this. medication statement or subject. Okay, let me just run the query quickly. So I'm going to show the query as it would have without a search. So where the subject is, let's hope this works. If it doesn't, because I got the parameter wrong. No, it does work. So it gets me, yeah, 12. As I said, 12 medication statements that are linked to this patient. But if I put them on the list, and I've shown you the list and only has 7, I can now get all the resources that are in that list. So if I get this one, I should not have 12, I should have 7, and that's it. So you see here, my screen has just updated with a list of 7. So I just got 7 resources. So this is just one other possibility. If you use lists, you can search things based on whether they belong to a list or not. So the other search that I was just running is the same as this one. So I'm just searching where the subject is a patient. So I'm going to, this is another search, get me all the observations for that patient. That's it. So now we are doing the more interesting part, which is combining all the resources together. So I want to search on observations, but the criteria, it's not in the observation, it's which patient we have. Okay, then I put here the patient reference. This is a simple example, because actually this is part of the observation. But I can do something more advanced, which is I want to get the medication statements, but I don't know if the patient is called patient 1023. I know that the patient has a unique identifier, which is a business identifier, which is UR01P, whatever, P004. So this is the let's say this is the actually I put it on the slides before. This is what we call a logical reference search. I had this in the example. This example here. So I can search for patients by ID, by the internal ID, or by the business identifier. So this will be like the passport number or the patient's social security number of a given country. And then I put the ID. So we can search by identifiers, not only by this internal ID, but actually by identifiers. We just have to express them. And the search, what the search does here is go to the medication statements. And I'm saying that I need the subject, I need to filter on the subject. So it resolves the subject and sees what patients have this identifier, and only returns the medication statements for that subject. So actually this should be the same as the other one. Yeah, which is actually why I did not put it there, or I hadn't put it there in the beginning. So I'm now just showing a bit how to chain searches. So we can search on one resource based on the resources that are referenced by this resource. We can have, so this is just another, the other example is just, we can do this by this type of identifier or by URN identifiers. So that's the same thing. It just gets me the results in a different server, but that's it. So this is the Graham server, this is Happy server. The behavior is the same. I'll go into a bit more of detail, although the documentation is all there, on how to use this syntax here. The most important, I think, is to wrap the syntax. So we have, for example, the ability to search for all the patients that have. So I want to search all the patients that have a specific type of medication request. Okay, so I can do this. I can say, get me all the patients that have a medication request pointing to it. So not the patient that points to something, but patient that something points to it. So in that case, I don't do this like this here, which is just a parameter, like I just put the reference data element. No, here I have to put patient that has a medication pointing to it. So this is actually not necessary, this last part. So if I send this search, I will have a search set. Yeah, so the patient, I'm getting all the patients that have a medication request pointing to it. I do not know how many I got. I can see the total here. I don't see total, and I don't see if there is a navigation aid. So I presume no. Yeah, there is more. So there are several patients that have medication requests pointing to it, which is normal. I don't see the total here, so that makes my life more complicated if I just want to look at this. So this is just another trick. So I'm just accumulating features here. There's another search parameter in those global search parameters that is the total or underscore total. And if I don't see the total, but I want to force that the search response returns the total, then I just put the underscore total and I put the word accurate. There's 3 values. I don't know if it's estimate or accurate or none, but in this case, the server really says, okay, I know you want the accurate total, so I have to run the entire search, see exactly how many results will be returned, and I just have to give you the first 10 or the first 20, in this case the first 20, but I will also tell the total. So this parameter is just one additional modifier of search, and the key thing is the underscore has that says I'm getting this patient based on other resources that point, based on conditions on other resources that point to this. And until here, I'm getting patients, but maybe I want to get patients and the medication requests. So there is another attribute, another search parameter, which is the underscore include. And in this case, I want to say I want to get the medication requests, and I want to include the patients that are referenced by the medication request. So this is the resource that I'm searching for, and this is the search parameter, because I don't want to look at the documentation. I trust that medication request has a search parameter called patient. And in that sense, because of that, I can say I want to include the medication requests that have, or I want to include the patients that are referenced by the medication request patient search parameter. So if I do this, I will get not only as a bundle, not only medication requests, but I will get patients. Let me see if I find one. I can search. Oh, somehow my searching not working. That's a demo effect, but I swear it was working yesterday. But I could navigate here. I presume that I would find something here about patients, the medication request, this to the medication request. Let me go further. Yeah, there it is. So I have one patient here. So this returns the medication requests and includes the patients that point to it. Oh, sorry, that are pointed to by the medication requests. So you can start chaining different types of resources in one search and getting them as result. So these are the reference patients, and like we had for the other example, we have the include and the rev include. So we have the patients, and in this case, it's not the patients that point to observations; it's the observations that point to patients. So I'm going to get one patient with this ID, and I want to include not the observations that the patient points to, because that does not exist, but I want to get the observations that point to this patient. So, and if I do this, then I get here the patients and the observations. Actually, here is the observations and the thing, and here should be a patient. Yeah, and here's the patient. So we are just cascading this search. We can do this this search. We can do the search by adding more and more resource types. As you can guess, so there's something that I would skip today. You can read it there, but you can say that you can. So I'll skip it because it's not working. I can get medications, but only the contained resources, or I can get everything excluding the contained resources, or I can just get the container resource, not the contained resources. So there's something that we can do on the contained resources. So, as a reminder, contained resources are resources within resources. So if I have a prescription, I can contain a medication resource inside a prescription. So I can say, get me all the medication resources, include the contained resources that are not in medications but in medication requests, for example. So include also those, And for those, don't give me the medication, but give me the container. So in this case, I would get a medication and the medication requests that would contain the medication. This was not working yesterday, so I would allow myself to skip that. A very brief intro to some parameter manipulation. I'll show the documentation for this, and then we go to the fun stuff, which is right close to our end. So let me see where we are in the presentation. We should be good. Yeah, so search parameters. We have just seen that there are global search parameters. There's search parameters for the results, and every resource will have their search parameters. And we have, but from this, oh, sorry, I have to have the screenshot. I'll have to go through the specification, which is actually better. When we have parameters, then until now we have seen just where the ID is this or where the gender is male. So this is simple. So this gets all the patients that gender is male. But what if I want to say I just want female and unknown and unavailable? So I can use that. I can use a different syntax. So I can have a specific modifier where the gender is not male, or I can have specific search parameter prefixes or kind of modifiers, and they are described here. So we have modifiers that we can say, for example, where is the not? There is the, yep, so there's a modifier not. That's the same example as I have. So the not just basically says, obviously, not this. So if I have gender male, if I say not gender male, that it includes everything that does not have gender male. So everything that is unknown female or is simply not given. So we have that kind of syntax that we can use, and we have other modifiers. For example, the equal. So the EQ is equal. We can do that, although when we say the equal sign, that's implicit. We can say NE is not equal, and more interesting, we can say, or more commonly, we can say greater than or less than, greater than or equal, and or less than equal, starts after and ends before. So these modifiers we can do, for example, for the simple example I have is patients that are younger than a certain age, or above 65. Let's say we want to get all those people vaccinated. So okay, this is the date. People that have a birth date less than this, then I send a request, and it only shows me the patients that were born before that date. So this is just the use of modifiers. As I said before, we can have the or. So we can have, if the comma is in the parameter, then this is an or. So I'm getting all the gender, where the gender is male or the gender is unknown. Yeah, so this is it. So we can use search, or we can use composite searches. So that's, and I think that's the final thing, that all of this is in the documentation, but so I'm just going to very quickly go through this. If you do gender male or unknown, that's all you can search on. But suppose that you want to search on something like, I want to search, so I want to get all the diagnostic reports. Move this out of my way. And so I want to get all the diagnostic reports, but of a given type, but that have a certain value. So you are in this case, we are combining the two things. We are saying, I want this to be, I want the code to be a certain procedure code, and I want to have a certain value on that code. So it's not sufficient that the code, let's say that we have an observation with two results, or with different, we have different observations, and they have different combinations of this. So what we want to have is all the observations that have this code, and for which the value, so the result for that code is above a certain limit. So we are combining two different search parameters, but we are accumulating them. We are not just saying it has to be this one or that one, and we are not saying it has to be it's not really an and. It's like, depending on this, check if this is, so depending if this is true, check if that is true. And in that case, we have this kind of expression. So it's a composite search. I had some issues with running this through a happy server, so I'm just using Graham's reference server for this. But this is the standard expression. So what we have here is that this is the code. So the syntax is that the result dot code, and we have the value and quantity. So we are going to express the value and quantity. So the code value and the quantity. So the code value is this, and the quantity is this. So we are running a search. Oh, sorry, and the unit is the quantity. The unit is part of the quantity. Just move this to the side a bit so that I can show it more easily. Yeah. So what I'm saying is that search where the code is this, and in that search where the quantity is greater than this. This in each parameter here, the same rules apply as before. We can use the modifiers, we can use just the values. But if I do this, I will only get, I don't know what result is this. I forgot. I had this. Okay. Actually, Graham's server does not respond to this. Let me see if Happy server does respond to this. Just one. Oops, this is wrong. Sorry. It's still doing something. Yeah, I had issues with this with a composite search. So that was what I wanted to share in terms of the syntax, so especially the modifier syntax. The next to this, what I would like to do is just to summarize with some guidance or some ideas about how to use this in a typical situation, and add some more magic dust to this, which is GraphQL. So I have. So besides this, okay, there's an issue here on both servers. Let me see if the other server actually has something. The Happy server. Yeah, not supported. So there's an issue in all the servers for the composite search. Apologies for that. I cannot demonstrate that, but if I cannot change it now. So before I go to the GraphQL, it's been a while. I've just been exposing everything that we have about search. Do you want? Do we want to have any discussion? Are there any questions, any concerns, any things that I missed? I did not look at the Google Docs, so apologies for that. Just please, while I get some water. Any ideas? Any thoughts? Any questions? I still need more water, so I would appreciate if we have any questions or any ideas or any complaints or anything. If not, then I presume that everyone is super excited because they have their own. You also have this information. And you are playing with it. So I just wanted to give some quick ideas on the advanced search. So composite is one of them. GraphQL is also an interesting one. This currently works on Graham's server. What I wanted to share, and we're really at the end of the presentation, so at the end we will stop for really please questions, but we don't have that yet, so since we don't have questions, just let me wrap up with the GraphQL. So GraphQL is a language that is, it's a specification, it's an open specification. It was originally made by Facebook because they had lots of performance and querying challenges to see who has a friend of who has a friend of who has a friend of has been in this event or whatever. So by traversing all of this graph of knowledge, they had to, or they invented a query language for that. It's used in many places in the industry. So FHIR also adopts or it also provides for that possibility. Depends on the server. Some servers might use it, some servers might not. But what it does is that we see FHIR not just as a set of resources, but as a connected graph of resources. And we can say, well, get me the patients that have this ID. So this is one query. Get me the patients that have this ID, but for this patient, only show me the ID and the active attributes. This is actually what it does. This is a simple query, and it's really not about returning the full resources. It's about really going through the resources and only figuring out the data, only getting the data that we really need. So if I run this against the server, I'm getting the patient that has this ID because I just filter this, and I get the ID and the active. If I remove the filter here, then I will get all the patients with the ID. Oh, actually, nope, ID is not found. And actually, I don't know if I can run this query. Yep. You see? Nope. Then I'm doing something wrong, and I don't know the syntax quite well. I have to read up on the syntax. I actually should. This should work. I'm doing something obviously wrong. But yeah, it's just another query language. So this is much more powerful because we can do things like this. We can say, get me the for this observation. So I'm just here. I'm just looking at all the patients. But here I'm saying for all the observations. Oh, sorry, for this observation only, run the query. And the query is get me the ID, get me the subject, and for that subject, get me, if it's of type patient, get me the gender and the name, and get me the code. So we can very easily traverse the graph of connected resources here. So let me just run this. And you see I have the observation, and then I have the patient, and this is, so this, while this ID is the ID of the observation and the code is the code of the observation, this is part of the patient data. So I'm actually here in this query, I'm actually combining the information between different resources and putting them together in one custom data structure. This is very powerful for querying, for analytics, for example, and it's of course very dangerous in terms of, because it just opened the door to getting all the data without any context, and you have to be careful also about privacy because you're making a very custom query on data. So this might mean some challenges in terms of controlling who can do what, but just wanted to show that this is the what we can do with GraphQL, so one of the advanced features of FHIR search. With that in mind, let's see something on the chat. Oh, there's still the Google Doc. I don't know if we have any hands raised. Just some, maybe then some quick notes on how to design or how to use this in a complete design. So let me see, where is the presentation? It's here. So from earlier sessions, you may remember that FHIR is pretty much on the data details and the data entity, on the physical data entity specification. So if you look at this from the architecture, from the enterprise architecture perspective, FHIR is, or the FHIR core specification is low level. It's on the level of physical and detailed stuff. Sometimes we have logical models, that's nice, and then we have the data models in a more abstract way, not in a physical way. Sometimes we can have some process diagrams when we do specifications. So when we do system specifications, we have to climb up this matrix a bit. We are not, sometimes we are just doing the physical specifications, sometimes we are doing a bit more than that. So in the case of search is important, is one of those cases. When we do search, you have to consider not only what can be done with search, but do I want to allow people to do this search? For example, I know that I can search for all of the patients that have a given condition, or I can run a search. There was actually a scandal a few months ago in Spain, because it was just possible to search for everything based on the national identity number. And I don't remember the details, but yeah, I think you pretty much could get the patient resource by querying the server if you just knew the patient national identifier. But apparently, the people that have public jobs in Spain, or some level of public jobs, maybe elected politicians, their ID number is of public domain. And that meant that people could actually search the details about the patient resource for those people. So you could see whether someone was registered and the marital status, etc. Things that really don't matter for people that are just, if you know the ID, that's one thing. If from that you can figure out the marital status and so on, and the next of kin, etc., that's something that's much more sensitive. So with this in mind, you have to see what are you enabling on searching. The same thing that if you want to search for some types of diseases, well, or some types of allergies, do you want to search for all? Do you want to allow searches like that, where the patient, like I had in my example, in many of my examples, I had the patient as a parameter here, so the patient ID. Sometimes I don't have. So in this case, I don't have. Do we want to allow these searches? Because if you do, then this means get me everything for all the patients, and that might put some stress on the decision on who can get which data. Whereas if you force the patient ID to be there, then you say, well, if someone has the ID, then this means that there's another part of the system that is assuring that by doing the search, the person has already granted themselves, or has already been granted the right privileges to run searches against this patient. So one thing is to run searches against all the patients, and then figuring out of which patients, which ones can I have the data, or as a physician, you're saying, I'm now entering the searches only for the space, or I'm now authorized to see data about this patient, and everything that I do is about this patient. So I have my freedom there is already well constrained, because I have established the permission to get data about this patient. So there is one dimension of business here that's not about technical, it's about what do you want to allow in terms of search. So privacy and the expected behavior, that's one thing. The other thing is the thing I mentioned with the search by GET and by POST requests. Keep that in mind, because when that happens, normally we have to get the opinion of the security experts or the infrastructure expert to see what kind of logs do we want, what kind of logs do we have. So this is something that we can have. Also define, there's servers that support the filter. So the filter is a wild card in terms of filter. So you can say, I can filter by these parameters, or I can make my own filter. So it's a bit like it has the same impact as the GraphQL. So we can do whatever search. Do you want to put that in the hands of a mobile application user? Maybe, maybe not. That's up to you. So try to define the search possibilities. One good trick that I personally use is always think in terms of transactions or interactions. So one thing is the interaction between a data analytics system and the FHIR server, which is getting everything, and they have the right to get everything. But maybe those guys, they don't get the names. Maybe they just get the IDs. That's one thing. The other thing is the doctor. The doctor will have every information, but one patient at a time. And those are different transactions, different system interactions. So that's one thing. The other thing is, as you start developing, it's with the scars of some past pains that I recommend that you should try to have a server with your reference content for testing. Otherwise, you try to search and you don't know if it's not working because someone has cleaned up or has expunged the reference server that you were using yesterday and today is not using, and today is not working. So try to have your own server when you develop content, and we can have some discussions on that, on how to set up a server rather quickly. But try to have your infrastructure under control. Otherwise, you will not know how many patients you'll get, because between yesterday and today, there was one guy in another continent that was using your test server, or the test server that you're using you just created lots of examples, or you just deleted lots of resources there. So those are some quick tricks that I could think of. And finally, very, very finally, because it was promised, there are custom search. You can add custom search parameters. So what if we need to search for patient marital status? What if there is a clinical circumstance or a statistical circumstance that we want to search by patient marital status? At this moment, as you've seen, we cannot. Or more likely, what if we make an extension? For example, what if we have the vaccination, and if we have in the vaccination we have the lot number in an extension, which we shouldn't have, but suppose that we have the serial number or the transport number in an extension in the vaccine. What if we make that extension, and what we want, and if we want to search that extension when running searches? As I said, FHIR makes everything computable. So there is a search, there's a resource type in FHIR called search parameter. I'm just going to open this. So if we want to add new search possibilities beyond what is defined in the out of the box FHIR specification, we can make search parameters. So if I make an implementation guide, I can say this implementation guide contains this profile, and it contains the search parameter that I want to use for searching the lot number or the manufacturer or whatever it is, or the marital status. So besides the patient search parameters, I can have a search parameter resource. I'll show you in a bit how it works. So this is just a technical way of defining what else can be searched upon. This is just a computable way of doing this in FHIR. I think the best is just to show how it looks like. So this is, so yeah, suppose that I have an extension called patients, the mother's maiden name. It's an extension that actually exists, but it's not searchable because it's an extension, or it's not searchable in the basic FHIR servers. So what we can create is, as part of our specifications, not narrative, but just computable content. So we can create this resource type, or this resource, it's of type search parameter, and it's really just creating a resource instance where we give it a URL. So this one has the defined URL, and basically what matters here is that the code is the mother's maiden name. So this is how I'm going to search for this, and the base is on patient. So this means that if I do this, I will be able to search mother's maiden name on patient resources. So it's almost like if I go to the patient's search parameters and I add this this additional parameter there, and the expression is this. So this basically tells the server when someone searches on mother's maiden name on the patient, you go to the patient.extension that has, so the patient extension that has this URL, and search in there. That's it. So that's what it searches. And if you go to the FHIR specification, you will see that everything that we've seen for the patient resource, all of these things, there are search parameters. So this is how FHIR works. We can extend the behavior of some servers. And just to wrap up this final part, so this is how the search parameter looks like. And there is some documentation on, for example, on Happy on how to do custom search parameters. I do not know technically how it's done. I know it's possible to do it, but those are the instructions in the documentation. And with that, we have seen how the search basics work, how we can do some more fancy searches. We have seen some business impact of the search and some design considerations of this, and how to actually extend the search possibilities. With this, I would invite for questions or for doubts or for anything that you wanted to see covered today that was not covered. Any ideas, any thoughts, anything's missing? Any things you want to explore further? even the awkward silence doesn't do it. So I guess there's really no more questions. So I don't know, Rhonda, if we should wrap up for today.
Yeah, sounds good. Well, I'll pause for just one more second. Any questions? Any questions for Jose at all? We've got lots of
Okay, then for my part, I hope it
everyone
was.
for coming. We have
Sorry, go ahead.
no, you're good. Thanks everyone for coming. So we have a fireside chat on November 19th, and our next fire session is on December 5th. We won't cover fire analytics. Both of the links to register are available in the Google Doc, and I will paste them here in the chat right now. The first is the fireside chat. The second is the analytics. The slides will be posted with the recording a little later this week on our wiki. So please feel free to come back and have a look. I think with that, thank you very much. It was a pleasure. Thanks, Jose.
Thank you. That was great.
Thanks. Bye-bye. See you soon.
All right.